Okay, today we're going to go over section 8.1, which is over the square root method of solving quadratics. But before we get started on that, let's first go over your finals. So this week doesn't have a regular test, right? If you look at the schedule, we're going to go over 8, 1, 2, and 3, Monday through Wednesday. Thursday, we're going to review for the final. Your final is Friday, okay? It will be open on Friday, all day Friday. So if you cannot get it done on Friday, you need to email me so I can make it open, an extra day. But I have to have it done by Friday, unless it's just some circumstance that there's no way you could actually sit down and take a 2-hour test on Friday. So I have it set up to be done that day. You need to get with me as soon as possible on that. Actually, if you can't, there won't be a regular test right over sections 8, 1, 2, and 3. But I'll tell you, a big chunk of the test, let's say a big chunk, more than a fifth of the test is going to be probably questions out of these 3 sections, because they're so important moving forward onto the college algebra section. So be prepared for that. Get in touch with me if you need any more information. That's fine. But I'll open it up like I've opened up every test, but it'll just be on Friday. It's not going to go through the weekend like the regular tests. Okay. And I do need to send an email out to everyone on that. I'll do that as soon as actually today. I can do that today. It's been a fun day so far. Okay. We're going to go to yep. Okay, so today we're going to go over the square root method. This shouldn't be a long lecture, which is nice. It's really just over solving quadratics. We've already done some basic solving quadratics by factoring. I think that was section 5.7. So this section really focuses on a very kind of almost a special situation. That's what I was going for. A special situation when you can just take the square root of both sides and solve it out that way. So let's get started. Let me switch over to my document camera. So before we get started, we have to talk about this square root property. And it says, look, if we know that some number squared equals another number, let's say we know that let's say we know that x squared equals 25. Okay, we know x squared equals 25, and we're trying to solve for x. It turns out the square root property says if you want to solve for x, you have to include the positive and negative of x. And it has to do so therefore x equals plus or minus 5. Okay, and the reason is if you square 5, of course you'll get 25. But also if you square negative 5, you would also get a positive 25. So there turns out to be 2 solutions for this equation because of the positive and negative. Positive squared, 5 squared, you get 25, and also negative squared, you get 25. Okay, so when I teach this, I really, I say, or my tip is when you take a square root of both sides, do not forget the plus or minus. Okay, for example, if we wanted to really solve one of these that's just set up perfectly, let's say y squared equals, let's say 20. So we'll simplify radical just to remember how to do that. Y squared equals 20. If I want to get the squared to go away, and this only works if you've got whatever is being squared on the left and a number on the right. Okay, that's it. That's the only time it really works. So if I want to solve for this y, I would take the square root of both sides because I know that cancels out the square. But when I do that, I'm going to attach a plus or minus, okay? Every time I put on a square root of both sides, when I take a square root of both sides, I attach a plus or minus to the number side. So we get y equals plus or minus the square root of 20. Now, I'm going to simplify this square root of 20, right? 20, 10 times 2, 5 times 2. So I could take a 2 out. And then I'm left with a 5. Right, I got a pair of 2s, and there's a 5 left over. So it becomes y equals plus or minus 2 square root of 5. So these 2 are really kind of basic square root questions. And that's what this section is about, is solving, the section is called solving the quadratic by completing the square. We're not going over completing the square. We're going to go over the square root property and how to solve with the square root property. Okay, so I'm going to kind of go through the steps on how to do this if we're given, a longer problem. So let's say I gave you, let's say x squared, 2x squared. 2x squared minus, doesn't really matter. Let's say minus 80 equals 0. So my indicator to use this square root property is that x squared I can get by itself. I can get whatever is squared by itself. So that's my indicator on when to use this property. So step one, if I can do this, if there was an x in here, if it was like x squared and then x and then 80, I wouldn't do this property, okay? But since x squared, I can get x squared by itself, that's my indicator to do this. So step one, I'm going to isolate the squared. I'm going to say component, because sometimes it's not always a squared term. So I'm going to isolate that squared term. So I've got to get this x squared by itself. So first, I'm going to add 80 to both sides. I get 2x squared equals 80. Then I'm divide by 2. And I get x squared equals 40. Okay, so I got x squared by itself, right? I added the 80 to both sides, and then I divided by the 2, and I get x squared equals 40. Now the second step, after you get it isolated, is take the square root of both sides. So take the square root of both sides. And don't forget the plus or minus, okay? Take the square root of both sides and do not forget the plus or minus. So I'm going to take the square root of both sides. And what that does is it gets rid of this square here, right? But I'm going to have to attach the plus or minus on the other side, on the number side, the 40. So we wind up with x equals plus or minus the square root of 40. So now step 3, I'm going to say simplify and solve. It doesn't matter really which way which order you do on that one. This one's nice because the x is already by itself. We'll get to examples where it doesn't get the x by itself. So let me see. Simplify / solve. Hold on, guys, 1 second.
So you did find your way back?
Yeah, don't worry about it. Sorry, I'm in the middle of lecture. I'll talk to you in a minute. Yeah, so we get x equals plus or minus the square root of 40. So now I'm going to simplify this 40 here. It's 20 times 2, 10 times 2, 5 times 2. Okay, so I've got a pair of 2's. I can take a 2 out. And then the 5 and the 2 don't pair up, so I'm going to multiply them underneath. So I get x equals plus or minus 2 square root of 10. So isolate the squared component, take the square root of both sides, don't forget the plus or minus, and then simplify or solve. Now this one was nice because the x was already by itself, so it solved pretty easy, okay? It solved pretty easy. Okay, let me do another one. I think I can fit it in right here maybe. This is more of just a reminder of how to simplify radicals than anything else, or simplify radicals more than anything else. So let's say we had let's say 4x plus 5 equals 0. 4x squared plus 5 equals 0. So I'm going to go through the same rigmarole. Isolate the radical, or not isolate the radical, isolate the squared component. So the x squared is here, I'm going to isolate it. So subtract the 5. So I get 4x squared equals negative 5. Divide by 4. And I get x squared equals negative 5/4. Now I'm going to take the square root of both sides, not forgetting the plus or minus. So x equals, so square root. X equals plus or minus the square root of negative 5/4. Now I got to remember how to simplify this radical. I remember if it's a square root, you take the square root of the top and the bottom. I'm going to go to the right here. Square root of negative 5 over the square root of negative 4, right? Square root of negative 5, now 5 is prime, but it's negative. So since it's prime, I I can't simplify the number, but because it's negative, I can pop the I out, right? So we get plus or minus I square root of 5. And the square root of 4 is just 2. So there's my solution. Actually, it's 2 solutions, right? Technically, you would write it like this. This is called set notation. Your book does write it like this sometimes. So notice it won't just be a plus or minus. It'll be I square root of 5 over 2, comma, negative I square root of 5 over 2. So it'll write it, actually, I think I might write it both ways. It writes it in this set notation with 2 distinct kind of answers there. Okay? 2 distinct answers. So remember the goal, isolate the square root, isolate the squared component, take the square root of both sides, and then simplify and solve, right? Simplifying sometimes turns out to be the harder part because we just don't remember. It's been a few days since we simplified. But that is our solutions. Okay, so let's look at one where we have to solve it out more. So we have to really dig to get the x. So let's say we had x minus 3 squared minus, doesn't matter, but let's say 12 equals 0. Okay, so this one is different. And it's because it's not just the x being squared, you have a binomial being squared. Now, if you wanted to solve this out by squaring it, remember you've got to multiply, x minus 3 times x minus 3, FOIL it out, then subtract the 12 with the positive 9 there, and then go that way. You can go that way. You're more than welcome to. I'll tell you, it's going to be a lot easier just to use the square root method on this one, okay? So if we add the 12 to the other side, because remember the goal is to isolate the squared component. That is our squared component now. Okay, so we isolated the squared component. Then we're going to take the square root of both sides. I'm not going to forget my plus or minus, okay, because I took the square root of both sides. The square root and the square cancel, so we get x minus 3 equals plus or minus the square root of 12, okay? X minus 3 equals plus or minus the square root of 12. So now I need to simplify that radical, but also I need to solve. I need to get this minus 3 to the other side. So I'm going to add the 3 to the other side. So I get x equals 3 plus or minus the square root of 12. And now I've got to, hold on a second. Now I've got to simplify the 12 here. So 12, that's 6 times 2, 3 times 2. Okay, I got a pair of 2s. I can take the 2 out. And I've got a 3 left over. So 3 plus or minus 2 square root of 3. So again, if you wanted to write it as the set notation, it would be 3 plus this 2 square root of 3, 3 minus 2 square root of 3. Okay? 3 minus 2 square root of 3. Let's steal some from the book now, just so, I mean, this is it, guys. This is the only part of this section I'm going to be covering. Oh, yeah, that's interesting. Okay, so let's do, this is number 22 in your book. It says 4y plus 2 squared equals negative 25. Hey, now what's nice about this, so number 22 on page 595. What's nice about this one is it's already solved for. The square component's already solved for. So I just have to take the square root of both sides here. So I get 4y plus 2 equals plus or minus the square root of negative 25, right? When you take the square root, it gives you the plus or minus the square root of negative 25. Now I'm going to simplify this out. I know the square root of 25 is just 5. 5, it's negative, so it's going to be I. So 4y plus 2 equals plus or minus 5i. So now we just have to solve for the y. So add the 2, divide the 4, right? I'm sorry, subtract the 2. So subtract the 2, that have -2 plus or minus 5i. Remember, we can't add these together because one's a real number and one's an imaginary number. So we leave them separate. So it's -2 plus or minus 5i. And then divide the 4. So we get y equals -2 plus or minus 5i all over 4. Boom. Okay. And that's my two answers. Now you can write this separate if you want. The -2 plus 5i over 4 or -2 minus 5 over 4. Either way is fine. Okay. Let's do one more example. And I mean, this will be it today. Not a long lecture. The next 2 lectures are going to be a little more stuff going on. Okay, so let's see. So let's do one that works out. If we had x minus 3 squared minus 16 equals 0. Okay, x minus 3 squared minus 16 equals 0. So I'm going to add 16 over. So I get x minus 3 squared equals 16. And then I'm going to take the square root of both sides. Don't forget the plus or minus. Okay. And now we get x minus 3 equals plus or minus. Now what's nice about this one is just 4. So x minus 3 equals plus or minus 4. Add the 3. So we get x equals 3 plus or minus 4. Now, what's different about this one is we can actually do the plus and the minus. Okay. So 3 plus 4 would be 7, and 3 minus 4 would be -1. So we have two real nice integer solutions, but I think it's the first time this happened, except for the very beginning. Remember, the very first ones were like plus or minus 5. But this can happen where you wind up with nice solutions. Now, again, if you wanted to write it out, you could write it like that, where the solutions are 7 and -1. And these are easy to check. 7 minus 3 is 4. 4 squared, 16 minus 16 equals 0. So it checks out. -1, same thing. -1 minus 3, -4. Square, you get a positive 16. Minus 16, you also get a 0. So this checks out. Okay. Pretty neat. And that's all of today's lecture. I mean, if you look on page 595, the homework that I want you to cover in this section is just, this is section 8.1, 1 through 1 through 25 odd. That's it. Just 1 through 25 odd. It's only about 12 or 13 questions. Get those done. And that's going to be, hold on, let me switch it back. That's going to be it for today's lecture. It's not a long lecture, guys. Just be prepared that, the final is coming up quickly. College algebra, which I haven't worked on. I've got to get working on that as well. We have a week off in between classes, I believe. I need to figure that out. I got to make sure that's true. We didn't have that last semester. But in the past, we took a week off in between. Hold on. Let me see. Got you for a few minutes. Academic calendar. You guys are spring 2021. March 8th. Yeah, we'll have a week off as well. So we'll have the test, our final on the 26th, February 26th, and then which is this Friday, and then you'll have a week off in between, and then we'll come back on March 8th for the second 7-week college algebra class. Okay. So if you have any questions about that, just email me. Kinley, if you've got any questions right now, let me know. But we are done, and I will